Well, hello everyone. This is a very unique situation. Um, I've never done this before, as you might imagine, and I think all of you know that I am not one of the more technical individuals in the world. But anyway, here we are, and this is going to be chapter 4 in the forensic book, and I will do the best I can. And I've already mounted on the board behind me some of the diagrams that I want to talk about a little bit more with you. Let me just make sure that everything is good. So I'm going to go around the back of this phone of mine and see if you all can see me properly. Well, what do you know? See, so far so good. Anyway, chapter 4 is on crime scene reconstruction. And most of what this chapter is about is actually specifically with blood reconstruction. Almost every facet of forensic science has a reconstruction mode to it, as you might all imagine. So they do at least indicate blood stain pattern analysis. This has been around for quite a while. It gained an awful lot of publicity during the O.J. Simpson trial. And that was such a key trial in forensic science. Of course, as you also know, this was also a trial of DNA. And, in other classes, I'll get into the O.J. Trial a little bit more. But anyway, this guy here, chapter 4, and I'm looking at the textbook, gets into some of the classic blood stain reconstruction techniques. The very first part of this, which is on page 80 and 81, is quite interesting. And that is that if a bullet is fired and from a shooter and hits an individual, hits an object or something, by looking at the angle, by determining the angle that the bullet entered or hit or struck something, you can reconstruct kind of where the shooter was. So what I did here was I took the figure 4-1 and I kind of put my own little play onto it so that you could see kind of how this is done. So here's the individual up here. And we'll say a bullet is fired at some upper angle down at the individual's head. Now, when you look at the blown up head here, there's a couple of things that become interesting. First of all, the cranium acts almost in a brittle manner, very similar to like a glass pane. And what you would see is you'd see a tiny little entrance hole, okay, on one side of the skull. And then if you looked inside of the skull, you would notice that that would be that blown out cone of depression that would develop. And then sometimes the bullet will go through that and go and hit the other side of the skull and give a blown out thing on the other side too. It's pretty amazing. The skull acts as an incredible impression piece of equipment. So once you get the angle, then you can go backward and determine just about where the shooter was when that shot was fired. The Kennedy assassination kind of had that type of analysis possible with it also. So that's what they're getting at there. That's the very beginnings of reconstruction. So then we go along, and I'm on now page 82 and 83. When blood is projected from a point of origin and hits a surface, depending on the angle of that projection, there'll be certain geometric configurations of the blood. So what I want you to think about is blood when it is projected. We'll think of it as a sphere, a spheroidal fluid that is running through the air, and when it hits a surface, depending on the angle, the momentum of this sphere, of this three-dimensional sphere, actually projects onto and across the surface it hits. So there are some relatively simple ones. This guy up here, for instance, is at 90 degrees. And if you think about it, if you stand and all of a sudden your nose starts bleeding, okay, the blood drops out of your nose and hits the ground surface at 90 degrees. And when that occurs, the geometry of that impact is this perfect circle where the width and the length would be, the diameters would be equal. That's the only situation where you get that 90 degrees. Now what happens when the angle of impact becomes less than 90? It goes from circular to elliptical in geometric design. So that means that this is 45 degrees. Notice that these little spikes are going out, pointing in the direction that the blood has been moving. So, and this is 30 degrees, more elliptical, again showing you that transport direction. So by looking at the geometry and the features of the blood impact stain on the surface, you can tell the direction from which it actually was projected. So it becomes more and more elliptical as the angle of impact becomes less and less. A couple of other things on this. So this is circular. This guy here is becoming elliptical at 45 degrees, and it has certain features. These are called spines or spikes. Sometimes what you'll get is when it hits, it'll also give little things out like this, which are called satellites. Now on 30 degrees, it becomes even more instructive, because here, think about the sphere coming in, hitting at 30 degrees, and most of it hits here, but then it slides off to give this what is called a tail. And by looking at all of this, you can determine quite a bit about, for instance, the point of origin of that blood at the crime scene. So that takes us down to here. How do I know exactly what the angle of impact for that blood would be? Well, down here I give you a real quick analysis of that. But before I even get into that, I want to draw your attention to page 83. And you'll notice here is a whole series, a swarm of blood. And these are very elliptical. They have tails, they have some satellites, etc., but all of them are pointing in the direction from left to right. And so we know that the point of origin of this blood had to be over here to the left somewhere. That becomes very critical. Another thing. So if you look down here at the bottom of 83, figure 4-4, you'll notice this guy in particular, a very elliptical blood stain, and then it kind of flowed down the surface. And then you'll notice at the bottom here, there is missing blood in the middle of this long, elongated tail. What does that mean? Well, if you think about this, so either one of these three bloods up here, when they first hit, the first thing that's going to dry will be the edge, where it's the thinnest, the edge of each of these blood impressions. So that means the edge dries first. The central bulk area remains wet for quite a bit longer. So during a struggle, or if somebody happens to push against this blood, they're going to take and remove the inside. That is a term that's illustrated kind of nicely here called skeletonization. So you see the skeletal outline of the blood, whereas the middle area has been removed by someone just impacting it, walking by it, hitting it, or whatever. So that's skeletonization, and that becomes important too. Another thing you can do is by looking at the environmental condition, blood is going to dry. And it's going to dry at a specific rate of time depending on temperature, wind, if there's any, etc., etc. So there are ways to quantify when this blood was spread. Let's get into reconstruction a little bit more. Down here, what I have done is I have put in a blood spatter that is probably 30 degrees or something. And there is a way to calculate the nearly precise angle that this blood hit that surface. And how do you do it? You have to look at the length of the bulk of the blood, not to the end of the tail, but the bulk of the blood, because if you think about it, this thing is coming in as a sphere, hits here first, and then the momentum of the projection pushes it out like that. So if I look at the bulk of the blood right in there and know that length, and I would measure it in millimeters, I told you that we would be dealing pretty much with the metric system when these things are measured, because it's very precise and easy to calculate stuff with. So I got the length, I measure in millimeters. I can also do the width, which is very easy in millimeters. And I know that the sine of the angle of projection that this blood hit is equal to the width that you measure divided by the length. Once you get W divided by L, you'll have a number, most cases less than 1.0, the sine of which will give you the angle of projection that this blood hit this surface. The only time it's a little confusing is when you have this 90 degree, because the length and the width are equal, giving you 1.0. And the sine of 90 degrees is 1.0. So that's how that all works. If we were in lab, I would have you play around with different angles and measuring to get the precise angle that the blood that you projected hit the surface. But unfortunately, frankly, I don't know whether we're ever going to see that. Which brings up another point that I probably should talk about at this point, and that is that I have to somehow make up for the labs. And the way I'm going to do it is I'm going to have you investigate various criminals and crimes, and I'm going to have each of you write an essay, in some cases opinion, about that particular thing that I'm going to have you look at. So for instance, next week, I'm going to have you look at a video about a guy that maybe you've heard of. If you watched Mindhunters, you certainly saw some examples of, and that is Ed Kemper. And I'm going to ask you to write me an essay, an opinion essay, on something associated with that individual who just happens to be a serial killer. Now, when you do those kind of assignments, I'm really, really interested in your opinion. Not Google's opinion, not Wikipedia's opinion. I want your opinion. And that's going to mean a lot to me, because that means you're thinking. Yeah, you can look up things, you can even reference some of those things, and that's nice, but I want to know what you feel. And I'm going to take you down that path for the rest of the semester. And we're going to do quite a few of those thinking things. It's the best I can do. So anyway, let's continue on this and see what's going on. So this calculation that I did for you is also noted here in the textbook on page 84, down at the bottom. It's a very interesting way to approach it. The most difficult part of this kind of calculation, I'll tell you, is figuring out the length. Where does the bulk of the blood end and then the run begin? That is why it's not a precise science. None of this stuff is. Another interesting thing, page 85, okay, down at the bottom. Sometimes a violent crime will have somebody bludgeoning an individual to death. And in this case, they're using a stick or a log, which I find very interesting because if you look into Ted Bundy's case, when he killed those co-eds down in Florida, he took a log from outside, brought it in, and just beat the heck out of them in their bed. Now, as you're doing that down motion, okay, what's going to happen is eventually blood is going to come out at the bottom of the instrument, the bludgeoning instrument. And as you reach up to go down for the next drop, what will happen is that blood down there will start to spatter out. And sometimes it'll hit the ceiling. Now, all you need to do then is, by knowing this kind of stuff, you can do calculations bringing back the angle of projection to the end of the instrument that was used to kill the person. So now if you know how high that is and you know what the instrument is, you might have a chance to indicate how tall the perpetrator is. I mean, it's just something I thought of. I don't know. It might work. It might not work. It makes sense. So there's that situation there. On page 86, we get into a very interesting calculation you can do with blood. And that is determine the point of origin. Now, in order to get a point, just like you've heard the term triangulation, like the GPS on your iPhone, how do they do that? Well, they got to have at least 3 different points that lead back to intersect at the point of origin. And what they're doing here on page 86 and page 87 is showing you how that is physically done. So I've done the same kind of thing. And if I can get this up on my makeshift board here, which I hopefully will do. I'll tell you one thing. This calls for innovative teaching. There's no question about that. You will never, ever forget this semester the rest of your life. And you will think back and say, wow, the pandemic. I can't believe it. As I told all of you, I'm going to do the best I can. And I'm hoping this works well. And if it doesn't, well, then what I'll do is I'll put my notes, and I will put most of my notes on the announcement, because most people see the announcement thing. That's like the first big deal. So always look at the announcement. And you can always email me, because I can get that too. Anyway, let's keep going on this so we get through this chapter. This is one of my favorite chapters, I will tell you. I have a book that I bought just on all of these types of analyses. Had I been stayed in forensic science after the Army, I probably would have focused on this. I find this a great combination of physics and common sense, and at that time it would have been innovative and probably would have been a great doctoral thesis. But anyway, I'm a geologist. So let's keep going. If you look at that page, figure 4-7, you will notice they've got a bunch of blood, and it seems that the blood is oriented in a circular way around something they have labeled in that figure on page 86 as convergence. So I've done the same thing. So if somebody is standing in front of a wall and a bullet goes through their head and out the back, it'll spray. And it'll spray in such a way that you'll have a distribution of these blood spatters, such as I've drawn in a very, very simplistic way. So I've given you 3 bloods here. Then we're going to say that they probably have projected out at about 30 degrees. Okay. The first thing you need to do when you're trying to find the point of origin is draw lines through the long dimension of the various bloods that you're going to use. So the long dimension, of course, is along L down here. Okay, so if you do that, and this is in 2 dimensions, on the surface of impact, then they will gather right around this point. And that is the point of convergence that they are talking about in the textbook. How do you put a 3rd dimension? Well, right by using this technique. So once you do W divided by L on all of the blood spatter points that you have, you'll have an angle of impact. So now all you need to do is, you know that this is the point of convergence, okay? You can then take a stick or a straight edge, bring it out perpendicular to that point of convergence, and then what you do is you lay a protractor on the blood spatters that you pick, and then by using a string can actually bring out the angle of all of those onto your straight edge. They will impact, we'll say right here. That is the point of origin of all of that blood. So now you know where the victim stood or whatever when they were struck by that bullet that went through their cranium. And that's all illustrated here. And it's also nicely illustrated, although I'm not a fan of Dexter. It's also nicely illustrated on Dexter. They do all the lines and stuff. That's the way it is physically done. And we would have had a lab just doing that. But, you know, what are you going to do? So regardless of all that, that's that little diddly. Then, you know, the rest of the chapter is pretty straightforward. There are there's some nice diagrams in here. I want you to look at all those. On page 93 is a nice example of skeletonization. Figure 4-17. Okay? But there's some really nice things in here. The last thing I guess I would get involved with is, how do you determine how many times the victim projected blood from the perpetrator? Now, in this case, you could only say once. Why? Because what you're really looking for is you're looking for an intersection of blood. So what if I do this? I have this guy come around like that. That's one projection. And now, of course, you know that this guy went like that. But then I have this guy like that. And this is telling me that this blood went like that. Not only that, I know that this blood had to come after this one. Why? Because it cuts right across that guy. That guy there had to be present before this blood was projected onto it. That's the only way that I can tell there were more than one bloodletting in this particular crime. So there's really nice pictures in here. They're colorful and all this kind of stuff. And there's a lot you can do with this. So where do we go from here? So what I would like you to do is, if we were in class right now, I would get through this, and then what I would do is I'd go on YouTube and Forensic Files, which you know I like to show you because it's short, but it's right to the point. And in this case, it's going to be dealing with blood reconstruction of a crime, and it's called Where the Blood Drops. So it's about 20 minutes long, so I'd like you to look at that. It's an interesting case, and that will kind of help you, I think, understand all of this stuff that I was talking about in the lecture. Well, anyway, that's our first From the Home lecture, and I hope that that all works out, and I will try to do another lecture. Please look at that announcement page, because I will be assigning things for you to do that you will be emailing me, and I can grade in lieu of actually sitting down doing a lab. And what we're going to do for exams, I don't know yet. I don't know yet. So everything is up in the air. I hope all of you are still healthy, safe, and I'm still alive and well. And so there it is, Lecture 1 from the Jackson home.